Practice 4-1. We start off knowing that each pair of polygons is congruent, so we need to find the measures of the numbered angles. Well, let's look at this. They didn't switch these around at all, so G goes with A and K goes with E, so that means that angle 1 would be 110 degrees, while angle K, or angle 2, would be 120 degrees. Then over here, we've got the right angle on M, which means that that would go with S, so angle 3 will be 90. Angle 4 matches up with angle R, so that would be 135. And then for number 3, let's zoom in a little bit. This one, they've actually swapped the sides. So A goes with F and B goes with G. It's pretty obvious how this will go, but this is one case where they've actually switched things around and you need to pay attention to which angle we're talking about. So angle 5, which is this one right here, that goes with this, matches up with the 140 degrees, so 5 is 140. Angle 6 goes with this right angle, makes it 90, and then angle 8 goes with angle Y for another 90 degree angle. Now, let's list 3 pairs of congruent sides. I would say A and C go with S and J, but I can't name them in order until I've looked carefully at the order that they give me here. So that means they named this C, start here, A, and then to T. And I'm putting little symbols here. Oops, it's supposed to be a happy face. There we go. So that I can go over to the other side and go in the same order with those same symbols, J, S, D. So I have to start with J, start at the star, go to S, and then finish at D. So now to name 3 pairs of congruent sides, now I can see the order that they have to go in. So the side CA, from star to the cloud, will go with JS. So there's one side. CA, congruent to JS. Do you see how I'm labeling each of these segments with the segment line over the top? Yep, that's important. That's just one pair. Let's name 2 more. Well, I've got A to T, which is cloud to smiley face. So I start over here, cloud to smiley face makes it SD. So A, T, congruent to SD. Now, if you've already done this and you said, but Mrs. Mitchell, what about TA congruent to DS? That's okay. Either one of these is fine as long as you have the A first and the S first. Oops, look at that, I forgot the symbol. Or if you chose the T first, then you have to have the D first. Last set. We've got C to T, which is star to smiley face, so it would be J to D, star to smiley face. CT, congruent to JD. And yes, you could have written this backwards, as if to say, start at the T, finish at the C, has to be congruent to starting at the D and ending at the J. Do you see how that works? Number 5, the 3 pairs of congruent angles. Well, they list these letters in order, so the angle that's at C would match up with the angle at J. So let's do this. C goes with J, A goes with S, and T would go with D. And so the answer for number 5 should be angle C is congruent to angle J, and angle A is congruent to angle S, angle S, and angle T is congruent to angle D. Number 6, 4 pairs of congruent sides. This is just the same kind of thing. We have to pay attention to the order that the letters go in up here, and that will be our clue as to how we can match these up. Sometimes the diagrams aren't so obvious, so you really have to pay attention to the letter order to know which thing goes with which side. So W is the first letter in this quadrilateral. J is the first letter on the other one. X is next, and that would go with K. Y is the third one. L is the third one. And then Z is last, so that must go with M. So now, to list the 4 pairs of congruent sides, if we start at W and go to X, that'll be congruent to starting at J and going to K. It's okay that they're not lined up. We're sort of going in this direction to get from W to X and going straight down to get from J to K. That's all right. As long as we match up these numbers and match up the letters and start at the same letters, then everything will be fine. So WX would be congruent to JK. Also, XY congruent to KL. Keep going. YZ congruent to LM. And ZW congruent to MJ. Are you wondering if you could give a different set of answers to these? Absolutely. This is one way to write the 4 sets of congruent sides. You could have switched the letters here under each one. You could have said XW, but if you said XW, then you have to say KJ on the other side. I wrote that wrong. KJ. Over here, just to drive the point home, if we start with Y and go to X, then we'll have to start at L and do K as the last one, etc., etc. How about the 4 pairs of congruent angles? I should have left the color coding, but I didn't, so let's do it all over again. W goes with J. X goes with K. Where am I getting that? I'm getting it from the letter order of, of the names. Z goes with M. So the 4 pairs of congruent angles would be W congruent to J, angle X congruent to angle K, angle Y congruent to angle L, and angle Z congruent to angle M. Number 8, state whether the pairs of figures are congruent and explain. Well, now, here's what we have to apply. They're showing us from these marks which things go together. So this G, angle G, is congruent to angle I. Now, if the entire triangle is congruent, then wherever the G is in the name, oh look, it's first. The I should be that same relative position for the other triangle. Oh look, it's first. Hey, this could be good. Now, if we go from G to H, that segment is shown as being congruent from I to H. So, in the name of the triangle, G to H, that's from the first vertex to the second. In the other name, we have to go I to H, and that's the first vertex to the second. So it's looking good. And then in this top triangle, the last corner is J, which is also congruent to the other angle down here. So those two match up at J, and sure enough, those are both in the 3rd position. So the answer to this one is yes. Now, let's check here. The first thing you should notice are the vertical angles. We have not yet conquered this as a class. So pay attention here. We got vertical angles. Where are the vertical angles? Right here and here. Vertical angles share a vertex and nothing more. So that means every time you draw the letter X, you have just drawn some perfect vertical angles because they share that point of the vertex, but no sides do they share. So we've got some vertical angles here. Vertical angles are always congruent. So I could say RSQ would be congruent to angle, should we name it VST or should we name it TSV? Well, let's see here. Since we landed at Q, which is 95 degrees, and that was the third letter that I wrote, let's talk about this angle as ending at the 95 degree one. So that would be VST to name this. So now I've just talked about angles that are congruent. Let's see if these triangles, the entire thing, is labeled correctly to make a congruence statement. Well, since I get the S in the middle, it's the second thing on both of these. So let's just make sure that this triangle is labeled with S in the same relative position. It is. It's the third thing in the name of the triangle, not just the angle. So then where do we go from there? Well, let's see. S is in the right spot. Q is matched up with T, so in this one, the Q should be in the same relative location as the T over here. So in the first triangle, Q is first. In the second triangle, T is first, which tells me that they do match up, or they should match up. And that's great, because they're congruent. And so if the Q is first, then the T is first. The S is last on both of them. That means there's only one other letter, and that has to match up. So, number 9, yes, this statement is true about these two triangles. So now, developing a proof. When they give you a problem like this with a bunch of statements about a diagram, the thing that they're looking for is a reason why each of these statements can be made. So now, we're going to look at the information here and decide how we can figure that out. So the diagram is all labeled, which means that anything that's on here is like having somebody give that information to you. So now, angle L congruent to angle Q. Why can we say that? Because the diagram says so. If you ever say to yourself, because the diagram says so, then the reason is simply that it's given. Now, L and M, so L and M, congruent to P and Q. P and Q. There's no label there. If there's no marking that shows you that it's congruent, then you've got to come up with some reason why these two angles could be congruent. We have this one and that one. Does that look familiar from about 2 minutes ago? It should, because those are vertical angles. So all you need to write here is vertical angles. I won't make you write vertical angles are always congruent. But that's the definition of vertical angles, so that's why we're writing it here. So vertical angles is the answer, the reason why I can make this statement. Next, angle M congruent to angle P. Angle M congruent to angle P. Well, that's funny. If I've got this angle matched up with this one, and this one matched up with this one, let me give it 2 arc marks. Then I'm trying to make a statement about a third angle. And do you remember on your note cards from this chapter, you can establish that when 2 angles in a triangle are congruent, then the third one has to also be congruent. Because if I put numbers on this, let's just say for the sake of variety, this is 60, which means this is 60. This is 60. So that has to be 60. Well, the only remaining answer here would be 60 on that one and 60 on that one. So I'm just inventing those numbers to prove the point that as soon as you get 2 angles in a triangle congruent to 2 others in a separate triangle, then the third set of angles will be congruent. You have it as theorem 4-1. So this one doesn't have a simple way to write it. So here we go. When two angles in a triangle are congruent to two angles in another triangle, the third set of angles will be congruent. Next, item D. We're saying that LM, let's clean this up a little bit. From L to M is congruent to QP. Why can we say that? Because it says so. Oh, that's my clue. The diagrams told me so. So these are actually all givens. So now, what reason do I have for saying that this entire triangle, LNM, is congruent to this entire other triangle, QNP? Well, we've got very simply the definition of congruent triangles. Sorry. And what is the definition of congruent triangles? 3 congruent angles and 3 congruent sides.